What's up, guys? Sparky Sean here at UBI Reseda College. Today we're doing PLC, specifically resistors. I feel like it's very valuable for you guys to understand how a resistor works and how to understand what the bands are. I'll get into that in a second. So first and foremost, the definition. A resistor is an electrical component that limits the flow of electric current in a circuit. That's what a resistor does. Okay. Next thing is the symbol for the resistor. Okay, and then this is the example of a resistor. Okay, now every resistor has bands. These are the bands in the resistor. So for this instance, we have the first band being blue. Okay, now that is a value. So if you look at my chart here, blue has a value of 6. Okay, so the first digit is going to be 6. And if we go to the next one, second digit is black. So 0, third, 0, and then we're going to get into our multiplier, okay? This comes on the fourth band, okay? So our multiplier for red is going to be 2. So this is times 2, okay? So this is a 4-band resistor. The first 3 digits do not add together, but in fact combine. So we don't add these, we are combining them, so it is literally 600 times, actually not 2, our multiplier is 100, which gives us 60K, or 60,000, okay? So that is how we find the resistance value per this resistor, okay? Now that's just a quick overview. There is other things to consider. If there's more bands, it goes into tolerance and temperature coefficient. I don't want to get into that today because I feel like just this right here is valuable enough by itself. This is what's practical and what I've seen personally on the exams. Okay, so the next thing, what if we don't know the bands, the colors, for instance, or the value, and we're trying to find the resistance knowing the voltage and amperage? So for this instance, we are trying to find the resistor value using Ohm's law. Ohm's law states resistance equals volts over amps, or divided by amps. So in our breadboard scenario that we're currently doing in PLC, we have a 9-volt battery, we have a 3-volt LED. So if we look on the board again, we are going to take our 9 volts, because that's our battery, minus 3 volts for the LED, which gives us a total of 6 volts. So that's our standard voltage now. So we take that 6 volts and we divide it by 20 milliamps. Now we're not going to use 20 milliamps. We're going to look it up and see what that actually equates to in amperage. What it equates to, 20 milliamps, is 0.02. And that's what we're going to divide it by here. 0.02 amps. What this equals is 300 ohms, or 300 resistance. Okay? So we have 2 different resistance values. We have a 60K and we have a 300 ohm. So again, let's look on the breadboard real quick. In this scenario for the breadboard, on the LED, we are starting out with our 60K. Now I couldn't find a 60K resistor, we're using a 51K resistor. And I'm going to show you the brightness of it. So it's pretty bright, but considering that's a lot of resistance. So I'm going to take out the 61,000 volt, or 61,000 resistor, excuse me, and I'm going to put in the 300. Okay, and you're going to see it that it's dimmer. Okay, so hopefully you guys like this video, this presentation. Please comment, like, subscribe.